When you first see this problem, the computer output jumps out at you. You know it has something to do with linear regression. And so let's just jump in. Part A, it says use the computer output to determine the equation of the least squares regression line. All right, that's pretty easy. So what I'm looking for is the y variable electricity production. It needs to have a hat on top, is equal to the y-intercept is 0.137, check. The slope is 0.240, check, and the x variable is wind velocity. You don't have to put the units here. All right, this person just happened to put the units here. But remember, looking at your computer output, here is the x variable, so that means this has to be the slope b. Here's the constant, so that has to be the y-intercept a, and we know that y hat is equal to a plus bx, and that formula is on the formula chart. All right, so if you got the right equation, that gives you 4 out of the 4 points. My person got all 4. All right, next part. How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles an hour? Show how you arrived at your answer. Now, you're going to need to show your work no matter what, whether they write it down or not. They're going to be expecting to see it, whether they tell you it outright. So in this case, you got to find out the predicted electricity produced for the 2 different wind velocities, and then you're going to find the difference. So let's see the work that's necessary. So in the formula, and I would prefer if you write the formula first, okay, just in case, all right? But showing substitution into the formula and then getting an answer, 6.137. Plugging in 15 into the formula, showing substitution, getting an answer, 3.737, check. All right, and then do you have a difference shown? Have you calculated that the difference? You got to show these 2 numbers are subtracted from each other. You got to show the work, and then you get the answer of 2.4, check. Now this is where I'm looking for units. Now I'm mainly looking for the units after the final answer. I love seeing the units along the way because they should be there, but the final check is going to be making sure that you have amperes or amps as your units for your final answer. So in this one, there are 7 checks here. My person has all 7 checks. All right, moving on to the third part. It says, what proportion of the variation in electricity production is explained by its linear relationship with wind velocity? Now, this problem is sort of like a rehash of one of the templates that you have to have memorized. This is actually wanting you to recognize that this is the interpretation of r squared. So let's see how it was graded. So looking up at the computer output, you have to remember you're never going to use the adjusted version, cross it out. So r squared, 87.3%, change it to a percentage. So check, of the variation, check, in the y, which would be electricity production, check, can be explained by its linear relationship, check, and then the x variable is wind velocity, and that will be your final check. And so that means in this case, there are 5 checks for part C. My person has all 5. All right. So this one, if you know your templates, you're in good shape. Don't go into the AP test unless you know the templates for interpreting slope, y-intercept, r squared, and the standard deviation of the residuals. You were good. All right, the last part says, is there statistically convincing evidence? Bing, 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 bing. Whenever you see evidence, you know you're going to be doing a test that electricity production is related to, okay, relationship, association to wind velocity. So because I have computer output, and I know it's a regression problem, there's only one choice of test that we can use here, and that is a linear regression t-test for the slope. And when we have computer output, everything is written there for you. You don't even have to use your calculator at all. But my person's answer was only that part right there. And they're not going to get a whole lot of credit except for the conclusion. So let me go through and just make sure you know how you're going to get full credit for the problem. So the first thing is the null hypothesis for linreg t, okay, test for the slope. Beta equals 0, the true population slope of the regression line is equal to 0, and there is no association between the two variables, wind velocity and electricity production. So that needs to be stated in here. Big check if you have it, okay? The ha is going to be beta is not equal to 0. Give yourself a check for that. And that in the actual words is that the true population slope of the regression line predicting electricity production from wind velocity is not equal to 0, and that there is an association between wind velocity and electricity production. So a check for that. All right, so check so far. Now, conditions, there are 4 conditions, but if you read in the problem, it tells you that all the conditions are met. It says all the assumptions were checked and determined to be reasonable. And so guess what? The only thing I'm looking for in the conditions is saying, since the problem states the conditions were met, I can do a linear regression t-test for the slope. Give yourself a check if you're using here, the linear regression t-test for the slope. The mechanics, all right, so I'm gonna, not everything you can find. All right, so what I'm looking for at the minimum, A equals 0.137, check. B, the slope is equal to 0.240, check. Have you written the word p-value? Okay, check. Did you write the p-value from your output, 0.000, check. And did you identify your t statistic? Check. Now remember, all that comes from the computer output. Now, if you knew the degrees of freedom, remember that would be equal to the number in your sample minus 2, but we don't know that in this particular problem, so there's no check mark for that. If you want to write down r squared and r, that'll be additional, but I'm only looking for 1, 2, 3, 4, 5 different checks here for this particular part, okay? So there were 5 for the mechanics, 1 for the condition, 4 for the hypothesis, all right? And now let's take a look at the conclusion. All right, so the first thing I'm looking for is using a linear regression t-test for the slope. It is missing here, so an X. They've stated their p-value, 0.000, and they have not used a math comparison word. They've used a symbol, but I'm still going to give them credit because they're saying that it's less than, and they have stated their alpha level is 0.05, so I'm going to give them their 4th check there. They actually got X, check, check, check. So that means it is lower, so that means we're going to reject the HO. So this person wrote down, we reject the claim, all right? So I'm going to give a check for I reject the HO. And now we're looking for the last 2 sentences. I have evidence, I have evidence. The first I have evidence is going to be in the words of the problem. It's going to be really statsy sounding. So my person does not have that. That it needs to be, I have evidence that the true population slope of the regression line predicting electricity production from wind velocity is not equal to 0, and that there is an association between wind velocity and electricity production. They do not have that, but they do have, there is evidence in the words of the question, so they are going to get a check mark for the last part. All right, so this conclusion right here is worth 7 checks again. All right, so there are a lot of different checks here that we're looking for. So for this 4th part, the D part right here, there are, oh my goodness, 4 plus 1, which is 5, plus another 5 is 10, plus 7 is 17. All right, so it looks like it's out of 17. I sure hope I added it up right. Okay, and so my person, let's see, my person actually didn't get a lot of this because I wrote all of this stuff in, but based on what I've written here, the only 2 things that they've missed are these 2 X's, so my person got 15 out of 17. All right, so now let's add all the points up. So we have 17 for part D, plus 5 for part C, that gets me up to 22. 22 and 7 is 29. 29 and 3 is 33. So overall, there are 33 points for this particular problem, and my person got 31 out of 33 of them. So mark that up at the top of the page, and we have now finished grading this question.